Thanks most for coming in. I hope more people will show up after lunch. The plan is to have several presentations here, and feel free to interact with questions. The idea is to how to optimize the SPEDAS software so that plugins will be easy, and we can bring in as many assets, data sets as possible into a common analysis program. So Jim here has been leading the effort within this group, but now it's becoming a community-based effort. Many people contribute.
Okay, well thanks. Thanks everybody for coming. Good to see so much interest in the community for this. It makes us really happy to see lots of people using our tools. So what we're going to do in this session is I'm going to go through a few slides and show sort of the current state of what's in SPEDAS. And then the next few months we're going to produce an updated release. So we're going to give you a preview of some of the new features we've implemented. And then we're going to have a few presentations of how other missions are using it. So Yoshimasa Tanaka from Ugonet could not be here, so I'm going to present a few slides on his behalf. And then we have Alexa Hoffler is going to talk a little bit about Barrel. And then Rob Redmond is going to talk a bit about some of Go's data sets. And then we have the rest of the time for discussion, Q&A, feature requests, whatever you want to talk about. So, there you go. So, this is SPEDAS. For if any of you have not heard of it or have heard of it and not used it yet, this is something we're trying to promote as a grassroots data analysis software for the space physics community. And this started out as a feminist-specific set of tools, but we realized that some of the tools were more widely useful. So we came up with this idea of sort of making a framework out of it that other missions could write plugins for, and sort of we supply the infrastructure, and they supply the bits and pieces that are specific to their mission, like load routines or analysis routines and plotting routines. So the idea is we would be able to have a group of plugins installed, and each one is maybe pulling data in a different data repository. And some of it may be in CDF format, some of it may be next CDF format, or so there might be database lookups. But really what we're trying to do is provide an environment where all these other missions can bring all these data sets together into one environment, and then use a common set of tools to analyze them, plot them together, and just take advantage of the synergy, all of the fleet of missions we've got going out there. So we have a lot of heritage in this. Some parts of the software date back to like fast and polar and cluster missions. Started out at the Berkeley Space Sciences Lab, and then a cast of dozens over the years have contributed various tools, bits and pieces. And then about 2 years ago, we decided to formalize it, give this product its own name, and that is now what is SPEDAS. And now the FEMIS mission is just another plugin among many. It doesn't have any special role anymore. We've managed to disentangle the general purpose infrastructure from all the FEMIS specific tools. The components of this framework are a GUI, so it's easy to use. You just point and click and select what you want to load. We have a lot of options for formatting plots, and we're really trying to make it as close to publication quality as we can get and write out of this software. But if you do need to do any tweaks for your own personal style, you can export the plots to EPS and then use like Adobe InDesign or whatever the tools to do the last few tweaks to it. So it's supported under Windows, Linux, Mac OS, Solaris. And basically, we get the multi-platform capability because we based it on IDL. So automatically, we get the benefit of running on most of the platforms that IDL supports, and they they're always making new releases, and patching and adding features. So let's just jump right in, and I'll show you a few screens. This is new in the SPEDAS 1.0 release from last year. This is not a plugin. This is actually part of the core SPEDAS, and this right off the bat gives you access to many data sets that are stored at the SPDF SPEDAS facility. This is sort of, it's all done on the fly. SPEDAS has a set of web services that they expose, and then the software behind this panel does queries to the web services to populate the various mission groups, and then the different instrument types that they support. And then once you select a mission and a data type, it makes some more queries and then populates this list of data sets. And then you can select a few of those to get data down at the bottom, and it goes out to see the web, downloads all the files it needs to, loads them into IDL, and then you've got it. You can work with it and do whatever you want with it.
So I would like to interject here from the point of view of the scientist that once the data are loaded in IDL, you can go use it from the command line.
Yes, yeah, that's right. The GUI, we like to expose as much as possible through the GUI because we have a population of users now who don't have IDL licenses, and this gives them a path to use it anyway, which I'll get to a little bit later. But yeah, we have a lot of powerful command line tools as well.
And you can sort of go back and forth. A lot of the times my workflow is like, I'll load the data in the GUI just because it's more convenient, and then maybe I'll make the plots using the command line and vice versa.
Right, or export data to tplot variables and to do things like the command line that don't necessarily have GUI counterparts. And then you can import the results back into the GUI and then continue to do plots and analysis.
All right, again, so once users start using this, then they get tired of having to go through the GUI every single time, including another day. So is there a quick way of transforming the operations, the clicks from the GUI into commands in the command line, or a script that loading the web data?
We do keep a history of all the operations that have been done in the GUI, and sometimes you can go back to that, and that can help you produce a script, but it's hard to have to do that in a general enough way that it can exactly track what commands are being generated internally and exporting the script. So that's maybe a future direction we can look into.
We should try to streamline that.
Yeah.
Because I can see after a few times, somebody's reading my data from my BSP, because no longer want to do it through the GUI, but wants to do it from command.
Yeah, usually the flow is in the other direction. People develop a set of command line tools they like working with, and then sometimes that comes to us as a feature request. Can we put that into the GUI?
Oh, yeah.
So it can go both ways.
I mean, there are some, we worked on some features that are sort of in that direction, so that you can have templates to store your plot settings. So if you have a plot that you like and you want to redo it with a different set of data, you can use the template to do settings. And you can also, if you've gotten to a certain point and you want to, maybe done a bunch of operations, you can save it as what we call a GUI document. And then when you reopen it, then you can close it down, delete all your data. When you reopen it, it'll replay all of those operations back where you were and replicate that session.
Yeah, there's three different ways of doing it. Like we said, it'd be nice to streamline those, have them up there for people as choices.
Yeah, those GUI documents that Pat mentioned, that's very useful for, like if you loaded a bunch of data and made some plots, and then somebody else was interested and you want to sort of send it to them. You don't have to send all the data and the plots. You can just send them, well, okay, I did this set of scripts, or did this set of operations, and then you just export that, and it's basically the instructions for how to recreate it. And it's not that much human readable, but the GUI can read it and replay all those operations same set of data loaded and the same set of plots. So then, this is another thing that we came up with. And again, this is with an eye towards supporting users that might not have an ITL license. Sometimes you might get some data loaded, maybe it's in the wrong units. This is an easy way to do sort of simple calculations with the data. We can just refer to them by their names. Basically, you give this calc routine a string that's with some expression in the compute. And then we have some routines that actually Pat wrote that will actually parse that. It is like a mini programming language. And it'll parse it, it'll execute them on the fly using things that are sort of friendly to the virtual machine environment. We don't have actual execute calls in there because that's disallowed in the license-free version. But so this is sort of a workaround for some of those issues. And so we have, we support a pretty rich set of operations that you can do. And this slide is showing how you would do that on the command line. And we also have a GUI panel for that where you can, in this case, this is showing you a tree of the data quantities you already have loaded. So you can sort of pick things off the tree, and then those variable names appear in this panel. And then you can sort of edit that to reflect the operations you want to do. And then when you're happy with this program you've written, you can just click run, and it will parse and execute all those statements. And then whatever new variables were created will get exported back into the data tree here for later use. Then this is another core SPEDAS capability. We have the capability of doing magnetic field modeling. This is also available from the command line, but in this case I'm showing the GUI panel, where in GUI you go to the analysis menu, and we have this magnetic field models. And this is sort of a wrapper around the GeoPack library, the Sigma modeling routines. And this lets you pick a variable that has, say, orbital positions in it. In this case, we have a famous position variable, position versus time. And then you can put in, some of the solar wind parameters, the neosphere parameters, and so forth. Choose which of the models you want to use, and then you can do things like model what is the model say the field will be at those positions. Or you can trace the field lines to the equator, trace it to the ionosphere. And so again, this you can pick the parameters, you click generate, and then it generates some output variables.
So when you're tracing to the ionosphere, what height is that at?
I don't know.
I think 100
Kilometers? Okay.
So that's that. We've had interest in the past at these meetings for people who are interested in doing modeling, so this is good enough.
You could probably have access to their own code.
Yeah, we have wrappers around most of the GeoPack routines that work with our T-plot variables, just for convenience.
You can have access to that, and I think the Sigma Fortran is also available, but I don't think that the GeoPack source is available. So that's sort of...
Oh, that's true,
yeah.
right. So, HiAcore builds the binary libraries for each platform he supports. And this is actually for the source code distribution. If you have an IDL license, the way most people get SPEDAS is to just download the source code, put it on the IDL pad and run it. This would be usually a separate download that you have to do. We download it from IA's site and get the DLM and the platform-specific library. And then our wrappers check to make sure that the right version of the library is loaded.
Are you thinking of a specific output trace to, because that is doable.
Storing the boots.
So we can make that a keyword.
Yeah, or to trace from our balloons up to the magnetic equator. That would be nice too.
Oh, that can be done now.
Yeah,
You
that
can
does,
just
yeah,
specify
that
a
is,
balloon.
yeah. But yeah, it would make it easy, because right now we use Geopack to do T89 for 2 different KP levels, so it'd be nice to have an easy way to do TSO4 or something.
Yeah, all of that is available from the
Yeah.
atmosphere out, but from the atmosphere down, the altitude I don't think is a keyword at the moment. But we
Yeah.
can make that a keyword.
Well, 100 kilometers isn't too far off, and it's fairly straight there, so it's probably okay. But I was just curious if it's 100 or 2RE or something, or, yeah.
Pat, if you're able, could you capture that as a feature request?
Oh, yeah, absolutely. I was actually just looking at the Fortran to see if I can figure it out.
Let's not worry about it real time, but it's more important to
Yeah.
actually capture what's happening. So
Yeah,
I
well,
think we could take
I'll take it.
Okay. Okay, so let's move on. And this is our data analysis panel, again in the GUI. So back up on this is the data processing widget. And then, so again, this is core SPEDAS. And we have a set of common operations going down the right-hand side. So the idea is, you see this loaded data tree over and over. That's our main data structure for keeping track of what data is available. So you can pick a number of variables, click on the arrows to move them over into the active data area. And then when you click on one of these operations, the buttons down the right-hand side, it will apply that operation. And some of them have parameters you can set. It'll pop up a little window and ask you for smoothing widths or number of points or so forth. And then it will apply that operation to all the data you selected, and then it'll tack on some kind of suffix to it, and then you get the transform variables in the active data area, and they get put into the loaded data tree. Now we're getting into things that involve plugins a little more. This is our load data panel. This is just from the file menu, load data, and you get this panel that comes up. And each tab represents a different plugin that's been installed. And so this is not quite current because this is missing. We now have an MMS tab. We also have a pose tab. We can see that we have a couple of feminist tabs here, pose, win, ace, so forth. And so what we're showing is the Uconet load data tab. And they have a very wide variety of instruments and data sets you can choose from. And I'll get into that a little bit more. I have a presentation I'll be giving that shows the scope of what they've implemented. So the idea is that most of the tabs work pretty much the same way. You pick a range of dates you want to work with. You pick an instrument type, and then you pick an instrument type that populates the available data types, parameters, and levels of data you have access to. And so you click around in here, pick which quantities you want to load, click the right arrow, and then it will go out to whatever server has been configured for that plugin. You'll figure out which files it needs to download. It'll copy those to your local data repository on your laptop or whatever, and then it will load those quantities you requested into IDL, and then they'll show up in the loaded data tree. And then each plugin has some configuration settings associated with it. So for feathers, you can set where you want the local copy of the data to go. And the remote data directory would be the feathers server, or we have several mirrors in various places. UCLA, I believe there's one in Europe, there might be one in Japan. And then a few other flags sometimes, like if you don't have a network connection, you might want to use local data only, so it doesn't even try to go out and connect to the remote sites. And then you can control internally, we have a lot of progress messages, debugging messages, and so you can sort of pick how noisy you want the logs to be. Like if you're really troubleshooting a problem, you might want to turn that up so you get all the progress messages. Or if you're sick of seeing it, you can turn it down so you only get the most critical errors and warnings. And then you can save, you can edit these, or just use those parameters for one session, or you can reset them to the defaults, or you can, if you have a set of parameters you prefer to use all the time, you can save it to a file, and then next time you start IDO, it will have all the settings customized. And then here we're just showing an example of taking data from two different missions and loading them and then plotting them all on the same timeline. As you can see, we have line plots and spectrogram plots, two of the most common plot types. And here's another set of spectra from some UGONet data. And this is, this I believe was generated from the UGONet plugin. And they have some of their own plotting routines. So they have a way to plot super darn radar data on top of the FEMIS ground-based observatory pulse sky imagers. Okay, so what I've shown you, most of that has been in SPEDAS since the previous release. And we're pretty much done with the set of features we want to add for the next release, SPEDAS 1.1. So we're going to be starting QA very soon on that. And we expect that to come out maybe late this summer, early fall. We do have a very expensive QA process for the framework because that affects everybody, so we want to make sure we get that right. For this release, we've removed a lot of residual dependencies on the FEMIS-specific code. For example, in the older version of SPEDAS, one of the data processing operations is a coordinate transformation, but it wasn't really called a general purpose routine. It was called a FEMIS code trans routine that has handles some of our specific coordinate systems that we're concerned with, but probably others are not so interested. So I think by now we've completely removed all vestiges of FEMIS code. So you could, I'm pretty sure at this point you could actually remove the FEMIS plugin, get rid of all that code, and SPEDAS will work just fine, and everything will still work. We have some new plugins coming down the line. There's an Akebona mission. This was developed, I think, by some of the same people that have worked on ERG and UGONet. We have a rudimentary MMS plugin that I believe it just handles a couple types of magnetometer data.
All of them. Like,
All of them.
level 1, level 2.
And we're sort of hashing out some issues now. They secured their server. We no longer have direct access to some of those files, but we're rectifying that so we access the data the way they support through their web services. And so that will be working in fairly short order. We've produced a pose plugin that can handle some of those data sets. That's available now.
All of them.
All of them?
The space physics one.
I wasn't really sure what that covered, if it was completed.
Yep.
Well, which ones are electrons and items?
Huh?
Electrons and items.
Yeah, is it VPED or TED? Do you know which instruments you're handling?
Oh,
Cover the NetCDF files or some other?
Yeah, from the NetCDF, I think.
Yeah, so you have VPED, TED, and
Sorry?
You have directional and omnidirectional detectors. If you have the whole, it's all the whole.
Yeah, we can both put the video on.
Yeah, that's right. Yeah.
Pat, did your SPEDAS installation here, are you working from a trunk or
Bleeding edge.
bleeding edge?
Yeah.
Well, maybe when we get to Pat's part of the presentation, we'll pull up that panel and see actually what's on it. Okay. Okay, so in this release, we've produced a few tools that should ease plugin development for other missions. We came up with this SPD download tool. For those of you who've written plugin routines, there's an older routine called file retrieve that got the job done, but it didn't really support the full set of features that we might want to use. For example, I don't think it handled secure logins. I don't think it handled HTTPS. And then some of our missions we're working with now require authentication to be able to get access to the data. So one way of doing that is to have a user and password embedded in the URL, and we support that now. Basically what we've done is we've replaced some of our homegrown code with the IDL or net URL object, which, so IDL has done the work of supporting all those features, and we're just making them available to plugin authors in an easy way. The prior version of SPEDAS did not natively support NetCDFs. Now we have that support in there, and we have a NetCDF to tplot routine. So if you've written plugins and if you've used CDF to tplot, this is the same thing for NetCDFs. So it just takes variables that are in the data file and loads them into tplot variables. And then, as I mentioned before, we've cleaned up the coordinate transformations. So we have this SPD cotrans that has just the well-known geophysical transforms, GEO, GEI, GSM, GSC, those sorts of things. We've added more hooks, so plugin authors can now attach some of their code to different parts of GUI. Previously, really all you could do was load the data. Now we have a place in the data analysis panel so that plugins can, on the fly, add items to there, and I'll show you how that looks in a minute. That's for operations that are sort of like what I showed on the data analysis panel. We have a set of variables that you're going to operate on, you're going to do something to them, and then produce a corresponding set of processed variables. Now, some data processing operations are a little more complicated than that. Maybe they involve plotting, or maybe they involve more complicated data flows. So we used to have a menu called plugins. We've renamed that to tools, which is a little more descriptive. And plugins can now add items to that and make them accessible to via the GUI. In the main GUI menu, on the right-hand side, there's a help menu. When you open that, we used to have an about option that would just show like the general SPEDAS, release, which release it is, it's some rudimentary information. I thought it would be useful to give plugins access to that, because that's a very convenient place to put things like credits or preferred acknowledgments for people who are going to use this data and publish with it, or if a mission has certain rules of the road that they want people to abide by, that's a good place to put them. So now plugins have a place to put those sorts of things. And the way this stuff all fits together is, all these features are completely optional. A plugin doesn't have to deal with them at all if you don't have any of those flavor features. But for the ones you do want to implement, it's pretty straightforward. For each plugin, there's an ASCII configuration file, and that's just sort of a list of like the GUI feature, and then you put in a corresponding, like the name of a routine in the plugin, and possibly with some other parameters. And then when the GUI starts up, it scans a directory for all these plugin configuration files, and then creates all the necessary menus and sub-menus. So that takes a lot of the drudge work away from the plugin developers. So it lets us leverage things that we've already written. So I'm going to show you a few examples of how these things work. So this is, okay, so this is the, so a plugin wants to add routine to the data analysis panel. This is how it works. Zoomed in a little bit, you can call those buttons of operations down the right-hand side. And now we have a more button. And when you click more, you get things that have been defined by plugins. So these two are some things that the Themis plugin supplies. We have a superposed epoch analysis tool. And then this is where we stuck our Themis coordinate transform. So this used to be the one that was implemented in the default data analysis panel. We've moved that down into a plugin routine. So none of that's gone away. It's just a plugin function now. And you can see like the DSL, SSL, SPG, those are all Themis specific coordinate systems. And this is just a shot of when you choose the superposed analysis tool. So it's operating again on this active data area. And these are the parameters you can choose. And hit OK, you get some new variables. Okay, and this is what one of these plugin configuration files look like. You have a line on there that says, okay, this is for Themis, and we use that like in the load data panel. That'll be the name of the tab that comes up, so it's going to be the Themis tab. And if you recall, there were two Themis tabs on that load panel, and here's where they're defined. First one is the standard load data file, and then the other one is the Themis derived products, and that is the internal routine that's associated with that function. These are the two items we added to the data analysis window. This is our configuration panel, and then these are so that data process, the coordinate transform in our custom data processing menu, we implement that as I guess a set of calls to the same routine, but with different parameters to specify the target coordinate system. And then finally, this is our text that we include in the About Themis plugin. And then this is what the code side of it looks like. So, this is the name that was specified in that plugin configuration file. And then we have some sample implementations for like a trivial plugin, so you can see exactly what things need to be passed back and forth. You can see in this one, most of these will pass in the loaded data object. That's that data tree that you see in a bunch of the panels. GUI ID, I guess, is necessary for something like to identify which user or interface it goes with. And then most operations will want to write progress to there's a status bar at the bottom of a lot of these windows, and there's a history window that I mentioned at the beginning. So as you're doing operations, it's printing out a history of everything you've done in that session, so you can go back and refresh your memory about what operations you did. And then plugin structure, I'm not sure exactly how that's used, but that's I think that's like a plugin manager kind of object. So it might, my intention is not to document all this here, but just to show you both sides and how the configuration file links up to the code that the plugin developers supply. So for the next release, we're going to have some more flexibility in the way we, different missions release their own plugins and the way we distribute them or compile them. So I mentioned a couple times the SPEDAS 1.0 that came out last year. We started producing these executable releases. So we've actually purchased a separate license from Excelis that lets us redistribute the ideal runtime without the end users having to have a license for it. So for SPEDAS 1.1, what we did is we took the core, we took all the plugins that were current as of that time, and then we compiled all of those into a set of ideal.save files, and then there's a way to turn that into a platform-specific executable file. So we compile all this whole environment, the framework plus plugins, compile it down to a save file, which is generic, but to make the actual executable files, we have to do it on every platform that we support. So we've got support for Windows, Mac OS, and Linux. I don't think we actually do Solaris executables. And we've also, we also give you a few options. I think we did one set of deliverables that we compiled with Ideal 7.1, which there were some changes in the way some of the graphics work between Ideal 7 and Ideal 8 and above, and some people prefer the way the widgets looked in Ideal 7, so we give that as an option. We also did, I think Ideal 8.3 was probably the latest available when we did a release last year, so we built those. These executable releases also have we got permission from High to distribute the geopack library binaries along with this. So if you go this route, you don't even need to download geopack, it's built in for you. Now, before we had SPEDAS 1.0, we did something like this. We made the save files available, but the user would have to then go to Excelis, register on their site, click through all their marketing stuff, download the whole Ideal distribution, the whole thing, just to get the Ideal virtual machine player. And that was really kind of a hassle. So now, with SPEDAS 1.0, it's much, much easier now. They come to our, 1.0, we did this. They come to our website, they pick which platform, which Ideal version it was built with. They pick the executable that's right for their environment. They download that, and then that's all they have to do. They can just double-click the executable, and boom, they're in the GUI. Yeah, so I guess there's one downside to that. In this virtual machine environment, you do not have any access at all to the command line. You have access to everything that's exposed through the GUI, but nothing else. So I guess that's sort of what prompted us to have more of these plugin integration features, because we want to encourage plugin authors to make these features as widely accessible as possible, even to the people that don't have Ideal licenses. And we've got a lot of interest in this from our educational public outreach program. We have a lot of high school teachers who no way can they afford an Ideal license, but this gives them a way to have their students work through some simple data analysis tasks using real live data from real missions, like a very realistic way.
Have you thought about going to Python or something that's already freeware?
That would be such a huge rewrite. I just don't think that's ever going to happen. Yes?
What about sort of Ideal GDL?
Sorry?
What about GDL? Is it
share a lot of language.
GPL is really not mature enough to handle everything. Like in particular, the graphics subsystem is extremely rudimentary, and we really exercise all the nooks and crannies of like those graphics.
So is there no SPEDAS with command line?
Oh yes, we also release it the way we've always done it in the past, just a tarball of dot profiles, and you download that. And if you already have your ITL license, put it on your ITL tab.
Which is both that and the command line.
Yes.
Just making
Yeah. We have a live website, spedas.org, and we make all the SPEDAS and plugin downloads that we're talking about. Those are all available from the site. We also have a documentation wiki that we've been adding to over time that it documents a lot of the internal routines, a lot of data processing operations, a lot of the issues that plugin authors face. We have a SPEDAS mailing list posted on this site, and a blog which we have not made much use of yet, but it's there if you want it. If any of you are currently developing plugins or know somebody who's thinking about it, or maybe on the fence, please point them to us. We encourage you to sign up for the mailing list and just cruise through there to see what we've got. And we hope people will find it interesting and useful.
Tell your friend.
Okay, so this is just a screenshot. This is what our new wiki page looks like, and then there are links all over the place from here to like the implementation details and plugins and guides and so forth. This is our download page. So we have some guidance here. Like we have all these different downloads now. Which one is right for you? So as I mentioned, source code is what we've always done in the past. That's just the tarball of dot profiles. This save file release. So maybe you're on some platform that we don't support, like FreeBSD or Solaris or what have you, and you already have the ideal virtual machine player. Then you can take these save files and then you can run these in the virtual machine and have at least access to the GUI. And then if you just want the turnkey single download for the platforms we support, as I mentioned, we have a couple different versions here. You can see compiled with 8.3 or 7.1. And I think we also give you a choice of which Geopack version is built into it. Yes?
Do you have a link for the leading edge version on there?
That I'm not. It may be farther down the page. I don't recall off the top of my head. But if it's not there, we probably could. Pardon? Oh no! Actually, I think what we did is on spedas.org. I think we set up a cron job on there to pull it from the Themis site every night. So I know. Okay, so somewhere on this site, the bleeding edge is available.
Okay.
I guess that's it for this portion of the proceedings. Yes?
As new data products are added to SPEDAS, are those automatically ingested into the SPEDAS?
I believe
Does
so.
it pull right from SPEDAS the available products?
Yeah, so I assume when they get a new data set, they vetted it, make sure it's in working order. They will add that to their web services, and then that should start showing up in the panel.
So then if you have a plugin for a specific mission, and you have that mission also has its data on CedaWeb, is when you go to CedaWeb, it's only grabbing the mission data from
From
CedaWeb
SPEDAS.
and not through the mission's level?
That's correct.
Okay.
And then you only get the data. You don't get any processing routines that might be associated with that plugin.
Okay, because right now our data is not the same on the two sites.
Yeah.
Yeah, the SEAL books sometimes send us new.
No,
It lags.
it's quite old,
Yeah.
yes.
So that's what the support